Hi everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, multiple choice question number 25. The question is, a parallel plate capacitor of capacitance C0 is charged to a voltage V and then the battery is disconnected. So a dielectric covering one-third area of each plate is now inserted as shown in the figure. So this one is your dielectric. If charges on the capacitor gets redistributed such that the portions covered with dielectric and not covered with the dielectric share equal amounts of charge. So this one that is covered with the dielectric and this one without dielectric shares the same amount, equal amount of charge. Which of the following statements are true? There are four options. So we should solve it and see which all options are correct. So option A is dielectric constant of the dielectric is 2. So first we will work on this. Then we will move further for charge disappearing due to polarization on the surface of the dielectric is 0.25 C0 V. Then we will go for C options, that is force of electrostatic interaction between portions of the plates covered with dielectric is equal to that between uncovered portions. And the D option is force of electrostatic interaction between the plates after ingestion of the dielectric becomes 9 by 8 times of its value before insertion of dielectric. Let us solve this. Collected all the data here for convenience. Parallel plate capacitor of capacitance C0. This one. A, we have assumed the area of the plate, and D is the gap between the capacitor plates. It has been charged to V and then battery disconnected. So initially, when there was no dielectric, it was charged to a voltage difference V, and then the battery is disconnected. So because of application of these V, we have assumed that the plus Q charge has come on this plate and minus Q charge has come up on this plate. A dielectric covering one-third of area of each plate is inserted as shown in the figure 1. So this is the dielectric which has been inserted here, and this area, plate area is A by 3. If the total area is A, then one-third of the area. So A by 3 is this area. Charges on the capacitor gets redistributed in such a way that the area covered by the dielectric and the area not covered has equal amount of charge. So initially, if we have assumed that Q charge was on this plate plus Q and minus Q was on this plate. So after insertion of dielectric, so Q by 2 charge has come up on this and Q by 2 charge has come up on this as per the question. So that has been shown in this figure. So capacitance C0, this capacitor, capacitance C0 is, since will be equal to epsilon naught A by D, that we know by formula, equation 1. The charge Q can be expressed in the terms of C0 into V. This is also by formula number 2. After inserting the dielectric of area A by 3, like this. This orange color is dielectric. For convenience, it has been shown as orange color. The capacitor can be considered as two capacitors connected in parallel. There is no issue in that because these two plates are connected with each other. So we can divide this into two capacitors connected with simply with the conductors at the end, conducting wires at the end, like this. And we say this capacitor now with dielectric as C1 is equal to Ct, C subscript D. D stands for dielectric. Area is A by 3 area. Charge is initially was Q, equal amount has to be shared as per question, so Q by 2. Similarly, this section without the dielectric we have given the name C2, C subscript 2. Its area is 2A by 3. So if we write the capacitance with the dielectric C subscript D will be equal to, by formula we know that it will be K times epsilon naught area of the plate. Area is A by 3 divided by separation of the plate. So we will reach to this equation K by 3 C naught, number 3 equation, where K is the dielectric constant. For capacitance C2, accordingly, we can write there is no dielectric here. We know that air is having the dielectric constant 1, so it will can straight away written as epsilon naught. Area is 2A by 3, separation is D. So we will reach to this equation 2 by 3 C naught, number 4 equation. Now voltage across the capacitor 1 or the capacitor which is having the dielectric on it with it is V dash, if we say it as V dash. So Q by 2 is the charge divided by the capacitance of that capacitor will be equal to V dash. We will put the value of capacitance C subscript D from equation 3 and will be reaching to this equation 3 by 2 Q by K C naught. Similarly, voltage across capacitor 2 if we notate it by V2. So we can reach to this equation 3 by 4 Q by C naught. But capacitor 1 and 2 are connected together through the conducting wire on the top and through the conducting wire at the bottom. So both the voltages should be equal because the capacitors are in parallel. So V dash will be equal to V2. We will put the value of V dash from here and V2 from here and we will get K is equal to 2. So our option A will be true. Now we know the formula for charge appearing due to polarization on dielectric will be, if we say it as Q dash will be equal to charge on the capacitor into 1 minus 1 divided by K. So upon solving we will be getting Q by 4 and we will be putting Q as C naught into V, that is 0.25 C naught V. So option B is also true. Let's work for option C and check. For the potential difference between the plates after the dielectric is inserted is V dash 3 is equal to 3 by 4 Q by C naught. Q by C naught is V, so you can write 3 by 4 times V. This is equation number 5. So energy stored in the portion of the capacitor covered with dielectric, if we say it as U subscript D, so U subscript D will be half into capacitance with the dielectric and voltage across, square of the voltage across it, so V dash square. Putting the value, we will be getting UD as 3 by 16 C naught into V square. This energy can be written in the terms of force as force acting to separate these two plates with Q by 2 charge and minus Q by 2 charge and dielectric inserted in between by a distance t. So Fd into d will be the work done, and this will be storing it as electrostatic interaction energy in capacitor with the dielectric. So this we say it as equation 6. Energy stored in the portion 2a by 3 of the capacitor not covered with the dielectric, we have written UWD. W is without and D stands for dielectric. So we will again calculate for it. That also is coming to 3 by 16 C naught V square. So that also we can write in the terms of work done as force into D. So from 6 and 7 we can make out that FWD is equal to FD. So option C should also be true. But in the book, answer C has not been shown as true, so this has to be checked. If any place some calculation mistake is there, but it does not look like. Now we will check for option D. The portion A by 3 of the capacitor without the dielectric has the energy without the dielectric is this much. UWD if we write. W stand for without and D for dielectric. So half into CWD into V square. CWD will be epsilon naught A by 3 into D. A by 3 is the plate area and D is the separation. V square, so we will be getting 1 by 6 C naught V square. And that we can write the force without dielectric dot D. So this is the work done when there was no dielectric on the capacitor having the area A by 3. So dividing equation 6 by 8, we will be getting this much. Fd divided by Fwd is equal to 9 by 8. Fd is the force with the dielectric and Fwd is force without dielectric. So 9 by 8. So if you see, the option D is having this. So option D also is true. Hopefully you understood the concept. In case any issue in understanding at any point, please do let me know. Answer C has to be checked for calculation. If the calculation is okay, then answer C should also be true. Thank you.